Hello guys, welcome to DTW tutorials. Okay, I know we're all wondering what's happening here. Okay, this is a continuation of resistors in series and in parallel. Okay, so in this video I'm taking you through the explanation, okay, practical explanation, as I promised to take you through. And if this is your first time on this channel, DTW tutorial is an educational channel that supports students in their WAEC physics, in their maths, WAEC, also JAM, post-UME, NECO, GC, name it. We support you. Even in junior WAEC, we support you academically. Okay, so if it's your first time, please try to just click the subscribe button. Okay, support us, support this ministry to move forward, and also support us to do more. If you like what we're doing, give this video a thumbs up and also share this video with your friends and family. Please share this video, okay, to reach out to other students. This is a free platform that supports students with their academics, so please try to share. Okay, so now today's video I'm going to be telling you the difference, as in practical difference with a series circuit and a parallel circuit. That's resistors in series and also resistors in parallel. All right, so now this is an example of a resistor in series. As I told you, there are three things you note in the resistors in series. They are connected end to end. You can see this end is connected to this end, this end is connected to this end. And the second thing to note in resistors in series is that the voltages across each resistance is different. That's why you can see these bulbs, they are not bright. Okay, now you can see a parallel circuit here. You can see all the three bulbs are bright, because you remember in parallel circuit, now I'm taking the differences. In parallel circuit, the same voltage flow across each of the resistors. So each of these bulbs have a particular resistance. Okay, so you can see this bulb has a resistance of 10 ohms, 15 ohms, 20 ohms. This one also 10 ohms, 15 ohms, and 20 ohms. And the battery power, the voltage is 9 volts. Now we can check this out with our voltmeter. If we measure the voltage across this, you can see we have 2 volts. Can you see that? Remember, the voltage in a series circuit is across each of the resistors is different. All right, so it is shared. That's the total voltage is shared across each of the resistors. So for R1, you can see a 2 volts. Let's measure R2. That's your 15 ohm resistor. Okay, you can see a 3 volts. Now for the last R3, that's your 20 ohm resistor, you have 4 volts. And if you add that up, we had a 2 here, we had a 3 here, that is 5, plus 4, we have 9. So the total volts in the circuit. So in a series arrangement of resistors, the voltages are being shared. That's the total voltage is shared between the resistors. And the same current, we can measure current. Okay, so we have an ammeter here. You can see 0.2, 0.2, 0.2, 0.2 amps, 0.2 amps in the circuit. So the same current flows through the arrangement in series. That's resistors in series. Okay, so now let's go check out our resistors in parallel. Now you can see that when I was explaining in a video, try to watch the previous video on resistors in parallel, I explained that the same voltage would be across each of the resistors. Okay, the same voltage will flow across each of the resistors, but different currents. All right, the current will be shared across each resistors. Now let's measure this to test what we are saying. Okay, so what's the voltage across the first resistor? Let's put our probe here. You know, if you don't place your probe well, you see a negative sign. Okay, that's when you're in the lab. All right, so the first resistor, which is 10 ohms, we measure a 9 volts, which is the total voltage in the circuit. Now let's check out our next resistor, which is 15 ohms, we still measure what? 9 volts. Now let's check the last resistor, which is what? 20 ohms, and we still measure a what? 9 volts. So it confirms that in a parallel arrangement, in a parallel arrangement, the same voltage flows through each of the resistors. Now this is likened to your bulbs in the house. Now let's bring this to real life, which the next video will be on our project, a practical project, real life example, where we'll build an extension box. Okay, so each of the bulbs in your house, they are all connected in parallel. Why? Because the same voltage would flow through it. And if you disconnect one, let's say we come here and let's say you put off one bulb, you can see it has not affected anyone. All right, the only way that you won't get any electric supply to the 3 bulbs is if you disconnect from the mains supply. All right, that's your distribution box. Okay, let's not go there, it's not for your level yet. Okay, so in your houses, the way bulbs are connected are it's just a simple application of resistors in parallel, because the same voltage will flow. You could see each. Don't you wonder why each bulbs are bright? How are they connected? Why? How? You ask yourself that question, and it's just the same simple principle of what? Resistors in parallel. The way everything is connected in your house. This could be, for instance, this could be a gas cooker, electric cooker. This can be an iron. This can be maybe an electric fan. Okay, so the arrangement of several appliances in parallel, the advanced calculation you have to, every appliance have a power rating, so you have to know which 2 appliances you can put in parallel. You understand what I mean? Okay, you might not understand what I mean, but in the future, if you go into electrical engineering, you understand better. But for simple life practicals, this is the way bulbs are being connected in your house. That is resistors in parallel, since the same voltage would flow through each bulb, so each bulb would be bright. Okay, so we've confirmed 1, the same voltage flow through each bulb, and remember, in resistors in parallel, it is arranged side by side. That's your negative to negative, your positive to what? Positive. Okay, so and let's check the current. And as I told you, current in a parallel circuit is what? It splits. So we can see from here the total current entering that would enter through this lane is what? 1.95. Now let's check what will enter here. We have 0.9, here we have 0.6, and here we have 0.45. If we add these 3 current values up, we are going to get what? A 1.95 amp. So 3 things to note in a resistor arranged in parallel: it is arranged side by side. Second, the voltage is the same across each of the resistors. And third, we have different current flowing through each of the resistors. Okay, so thank you. I hope this video helped you. If it did, please give this video a thumbs up to encourage us to do more, and don't forget to subscribe. And remember, Jesus Christ is coming soon. You are destined to win. Please give your life to Christ. He is the only way to salvation and eternal life.